Daniel is here, and welcome to another episode of the Data Science TLDR, where we take long papers and make them short and concise. So today we have a really cool one. It's called Schrodinger's Memory, Large Language Models. Okay, so just by the name, I liked it. So I said, let's review it. It's by two researchers from the Hong Kong University. And in the abstract, they say, uh, do LLMs have memory? Based on current performance, LLMs do appear to exhibit memory. So, what is this underlying mechanism of this memory? Previous research has lacked a deep exploration of LLM's memory capabilities and that underlying theory. In this paper, we use Universal Approximation Theorem, UAT, to explain the memory mechanism in LLMs. So if we go to the introduction, the authors discuss two methods to improve memory in LLMs, expanding the contents length and using external memory systems. However, these methods fail to fully capture how memory functions inside models. Using the universal approximation theorem, the authors argue that LLMs approximate memory by dynamically fitting input to output, similar to how neural networks approximate any function. This mechanism explains how LLMs generate answers based on past data when prompted with specific queries. Let's go to the memory section. Here they present UAT in LLMs, and we won't go in the math here. If you like the math, you can follow and check out our podcast where we dive deep in historical papers. So in chapter number 3, memory, they say that LLM's memory capabilities they test LLM's memory capabilities by having them recall poems based on minimum input. The model successfully remembered poems from both Chinese and English datasets, demonstrating that they do have a memory-like function triggered by input cues. If we go to the chapter that is comparing it to human, they give all the examples. Chapter number 4 is comparison between humans and LLMs. They suggest that both human brains and LLMs rely on input to trigger memory. However, they acknowledge that human memory involves distributed neural processes, right? We don't know exactly where things stored here. So maybe in a hippocampus, while LLMs dynamically generate responses without fixed storage. Key factors affecting LLM performance include model size, data quality, and the architecture. So my view, I'm not a neuroscientist, but they do provide a compelling analogy for LLM memory, but they oversimplify the comparison to our memory, right? Which remains poorly understood and also involves distributed processing across various areas of our brain. And they assume in the paper a straightforward input-output model. But our memory is more complex and have emotional, spatial, and sensory components integrated across the brain. So to conclude, I think it was a novel idea and a perspective on how LLMs handle memory, the using of UAT. However, as I said, the comparison lacks real value and various intricacies of biological memory are not really accounted, right? Nonetheless, that was a cool idea, and I enjoy that researchers tackles various ideas around LLMs that comparing to what we do as humans. So if you like this, hit the subscribe button and see you next time.